I remember, or probably around a week ago now, I had a bit of an enlightening moment during meditation where I was able to equally divert my attention to two different things. I was able to completely and utterly focus on breathing while also still like working out and solving this sort of chemical problem that came into my head. And I've been learning about things such as reaction mechanisms recently, and my brain just had like a random split-second instant thought of how exactly do certain molecules react with each other, and how exactly do they react with each other. Not just the this plus this equals this plus this, but the things that happen, the whole polarized bonds and the whole electron donors, all that sort of stuff, the curly arrows that say where the electrons go, and all that sort of stuff. And the first one was on how does carbon dioxide dissolve in water and henceforth react with water. Carbon dioxide makes water more acidic when it dissolves in it because it forms something known as carbonic acid. This was something that I discovered when I was researching on a video about the urea cycle, because carbamoyl phosphate, one of the starting products of the urea cycle, is formed initially from carbon dioxide dissolving in water inside of the bloodstream, carbon dioxide that you breathe in from the air. So that's a very interesting thing. But it, like, split-second thought, I decided to divert my attention from both the breath, because this like the breathing is still relevant to what I've got to say here, as well as like figuring out how this whole mechanism worked. And I'll tell you how the mechanism worked. And it's just interesting how complicated this sort of mechanism is, while I was still able to completely consciously, without completely forgetting and just not thinking about it, still being able to somewhat have breathing correctly in my peripheral consciousness. But it starts with obviously carbon dioxide and water. Carbon dioxide is an incredibly polarized molecule. The carbon's going to have a very delta positive charge, and the two oxygens are going to be delta negative. Because there are two oxygens, it's going to be even more polar than when there's just one oxygen double bond and there's maybe like hydrogens or something, in the case of formaldehyde, off of the other two bonds that carbon has available to it. So these 4 electrons in each of the double bonds, because one bond contains 2 electrons, so a double bond contains 4 electrons, and there are 2 double bonds, so there's going to be 4 electrons that are each going to just be really quite far away from the carbon, so it's going to have such a huge delta positive charge. And water, the oxygen, because oxygen is more electronegative than hydrogen, is going to have a delta negative charge. This delta negative is going to be attracted to carbon's incredibly delta positive, and it's going to like start to form a bond. Now, what's going to happen when these molecules start to try to form a bond is, because carbon can only form 4 bonds and it's still got the double bonds attached to it, how's it going to be able to sort of accommodate the fact that it wants to bond with this water molecule? What it's going to do is one of the double bonds, only one, is going to open up. So oxygen is going to take half of the atoms from the double bond and keep it to itself. So they're not part of the bond anymore, and now there's only an OC single bond with 2 electrons, and the oxygen now has a lone pair. And that means that the water molecule can bond to the carbon, but oxygen can only bond 2 times, and now it's bonded to the carbon as well as 2 hydrogens that are part of the water molecule. So what's going to happen is, because the electrons in the OH bond, the spare OH bond, they're going to both go and return back to oxygen, and the H plus that is left is then going to attach to sort of form carbonic acid, where it's got a O and a C and then 2 OHs off the side. It's like a dicarboxylic acid, but it's not actually. Because carbonic acid is an acid, admittedly it's quite a weak acid, some of the molecules are going to be deprotonated, and so they're just going to have the O, the C, and then the 2 O's to make a CO3 2- ion, which you may have seen in some of your school classes and stuff like that. You may have heard that mentioned, like bicarbonate and all that sort of stuff. That is like formed from carbonic acid. That is the sort of main part of this. But that is essentially how carbonic acid is formed. It's not necessarily the most useful information, but what I find the most interesting about this is that I did this. It came to me without any sort of. It didn't take a while for this epiphany to sort of build up. It was just there, and I was able to divert my attention into solving the problem that was like in my mind that had like suddenly appeared. Like, oh, how exactly does carboxylic acid react with water to form carbonic acid? What is the mechanism there? As well as still consciously focus on the breath. That's the most interesting part to me, and I think if you currently do meditate, you will get those moments, and it's acceptable to me personally not to brush all the thoughts you get in meditation away, but to like keep your like some part, at least 50% of your consciousness on the breath, but also be able to tackle other issues and problems, because that is really building up a mentally strong mind, in my humble personal opinion, even though I'm still relatively inexperienced at meditation compared to a lot of like Buddhas and experts and all that sort of stuff. But that's just like my perspective and my opinion based off of this interesting occurrence. But with that, I recommend subscribing for more content like this, and have a nice day.